Hey there, and welcome. When you think of Hawaii, you probably picture amazing beaches and perfect sunshine. But just beneath the surface, this famous island chain is hiding a geological mystery that's millions of years in the making. So today, we're going to put on our detective hats and crack this case wide open. Okay, so just picture a map of Hawaii for a second. See anything odd? The islands aren't just a random cluster, are they? They form this perfect, neat line stretching across the Pacific. That's no accident. That's a clue, a trail of breadcrumbs left behind by one of the most powerful forces on our planet. So what is the secret here?
All right, so this is where our investigation kicks off, with this incredibly orderly line of islands. Starting from the big island of Hawaii and stretching northwest all the way to Kauai and even beyond. Each island is like a stepping stone from the last. This pattern? It's telling us a story about creation, about movement, and about a whole lot of time.
Now here's the absolute biggest clue we have. Geologists figured out that as you travel northwest along that chain, the islands get older and older. The Big Island? It's basically a geological baby, still having eruptions. But Kauai? Ancient. But how on earth do you figure out the birthday of a giant volcanic rock? Turns out, you need a very special kind of clock. To crack this case, we need a tool that can literally look back millions of years. And that tool is radioactive dating. I want you to think of it like a natural, atomic clock that starts ticking the very second a rock is formed. By reading this clock, we can figure out the age of each island with unbelievable accuracy. Okay, so the specific gizmo in our toolkit is an atom called beryllium-10. When volcanic rock first forms, it's got a certain amount of this radioactive stuff inside. It's kind of like a fading echo. This beryllium-10 slowly, steadily decays, turning into a stable atom that doesn't decay. So the more of those stable atoms we find, you guessed it, the older the rock is.
And how we use it is actually a pretty simple three-step process. No sweat. First, you count up both the radioactive atoms and the stable ones in a sample. Step 2, you figure out the percentage of the radioactive ones that are left. And boom, step 3, that percentage tells you exactly how long that atomic clock has been ticking. It gives us the rock's age.
And this right here, this is the simple little formula that's going to power our whole investigation. All we're doing is dividing the radioactive atoms that are left, that's the part, by the total number we started with, that's the whole. And just like that, we can unlock the age of every single island.
Okay, we've got our method down. Now it's time for the fun part, gathering the evidence. We're going to grab rock samples from each of the main islands and put them through our dating process. Let's start building our case file, shall we?
All right, check this out. This is our evidence log. For each island, from Hawaii to Kauai, we're going to run our beryllium-10 analysis. We'll count the atoms, get that percentage, and figure out the age. This is going to give us our first crucial set of clues.
But wait, age is only half the story. It's a big piece of the puzzle, for sure. But we need one more thing. The other crucial clue? It's distance. We need to measure how far each island is from the main volcanic hotspot, which right now is sitting right under the Big Island. Think of it as ground zero. We'll log each island's age right next to its distance.
Okay, we've got our evidence, we have the age of each island, and we have its distance from the hotspot. Now comes the best part of any detective story, laying all the clues out on the table and seeing what pattern jumps out at us.
And there it is. Wow, the pattern is crystal clear. You can't miss it. The data shows, without a doubt, that the farther away you get from that active hotspot, the older the islands get. This is not random, folks. This is a perfect record of a massive geological process. But what is it?
Okay, to really get this, let's use an analogy. Imagine the giant Pacific plate is just a huge piece of paper, and underneath it, there's a single unmoving candle flame. That's our hotspot. Now, what happens if you slowly drag that paper over the candle? The flame is going to burn a trail of scorch marks, right? Well, the Hawaiian Islands, they are those scorch marks. Each island is a burn mark left by the hotspot as the plate moved over it.
So, with that amazing picture in your mind, the candle and the paper, we've got everything we need to finally solve this case. All the evidence, the ages, the distances, it all points to one of the most fundamental ideas in all of geology. So, here it is, the final verdict, laid out plain and simple. Our claim? The Pacific Plate is moving in a northwest direction over a stationary hotspot. Our evidence? The islands get older and older the further northwest you go. And the reasoning that ties it all together? This is the exact pattern you'd expect to see if a massive tectonic plate was drifting over a fixed source of magma. Case closed. The Hawaiian Islands are literally a timeline, etched in stone, of the Pacific Plate's slow, unstoppable journey. So let's just quickly recap what we uncovered here. We found out that the Hawaiian Islands are basically a timeline of volcanic activity. Their ages and their positions are like a roadmap, showing us exactly how the Pacific Plate has been moving. And it's this incredible constructive process, building new land right up from the ocean floor. And the coolest part? We figured it all out using radioactive dating as our geological clock.
And that, of course, brings us to one last really cool thought. See, that candle is still burning. And that piece of paper? It's still moving. That very same hotspot that built all the islands we know and love is, as we speak, creating a brand new island. It's called Loihi, and it's still just under the waves. So I have to leave you with this question. This process isn't stopping. What do you think this incredible island chain is going to look like in another 5 million years?